All right. How's everybody doing? Good to see you guys all back again for another week here of our DSKUS program. Last week we covered the first global policy seminar, which we of course had a little reading for and watched a lecture from a faculty member at the Naval War College. For the second policy seminar, we've already kind of set up. We're going to actually have you guys hear from one of the diplomats at the U.S. Embassy here in Korea. So that'll be interesting. But for the next few weeks, we have to do some work. So we're setting up all your travel stuff right now. So that's plane tickets have been purchased actually, and hotel rooms are being booked, and we'll have some updates about some of that stuff. Some of the workshops are being set up with some pretty cool companies. But the next few weeks, we're gonna have to do some work. So in order to make all this work, they're actually expecting us to produce some good ideas about these problems that they wanted us to work on. I was just talking with the embassy a few days ago, and they're really actually excited to see what you guys come up with. So we have to try to do a good job on that part of the program, as well as try to have some fun. So the first month, you guys have mostly been focused on doing a lot of lit review, right? So the first month is really just learning about the project, kind of starting to look around for some data sets, identifying sources. You guys will have this annotated bibliography that's going to be due at, what is it due on the 8th? So I guess it's due on this coming Friday. So kind of keep that is the 8th Friday? I think it's due on the Friday. I think it's due on the 8th. But anyway, check the LMS. There's a date in there. That's the date it's due. But as we finish up the kind of background research, it's going to be time to start turning our attention to the next phase. So April is really a month of brainstorming. It means we're going to explore some data. We're going to try to generate some hypotheses that we can test. We're going to try to come up with some initial ideas of ways we could solve the problem based on the things that we've learned from our background research. So you can kind of think of the first month of this project as kind of just background research. The second month is brainstorming. And the third month, we're going to put it all together and kind of execute and hopefully, come up with a really good final analysis and a really good final proposal. So that's kind of how the program is laid out. So this middle month is really all about brainstorming ideas. We're going to talk about exploratory data analysis today and talk a little bit about feature selection and stuff like, or feature engineering and stuff like that. And then we'll talk a little bit in the coming weeks about creating some design sketches, which are basically just brainstorming on paper, and some other kind of things. We'll go through a series of weeks here where we basically just try to come up with ideas. Some of those based on some preliminary data analysis, but some of those are also going to be based on what we've learned from our background research. The goal of this month is not to solve the problem. Right now, we don't know enough to try to solve the problem, or any solution we come up with is going to be suboptimal. We need to try to explore as many possibilities, turn over as many stones, so that we can make sure that the path that we're going down is actually the best path. Right now, we don't know what that is. So we need to figure that out. So the first, one of the first parts of that is you guys have hopefully started to identify some data sets. Well, we need to start to look into those data sets and figure out what's there, right? What do we have to work with, right? What are the kinds of questions that we can ask, right? So I like to think of this as kind of continuing the hunt, right? We have some evidence, we have some clues, we have some hints, right? But what does it mean, right? What are the kinds of theories we could come up with about, how this crime was committed, who did what, who the suspect is, right? It's just like being a detective, right? It's just like being a detective. And so now we have to kind of start to try to put the clues together. We don't necessarily need to solve the whole crime just yet, but we need to start to kind of piece together the parts that we're working with to try to figure out, okay, where should we go next, right? So EDA, which is exploratory data analysis, is all built around this idea. Success in data science is usually, I would say 70% of it, 70%, maybe 80%, is making sure we start out asking the right questions. When I've been a practicing data scientist, what I have seen more often than not is when data science projects fail in the real world and industry, it's usually because people started off poorly, right? Or they start off with the wrong question, right? And if you start off with the wrong question, invariably you're going to end up with the wrong answer. So if we want to come up with the right answer, we got to make sure we're starting with the right question. It's not that complicated, right? But you would not believe how many times I've seen people screw this up in data science, practicing data scientists. It's a very simple idea, but people mess it up. They just get too excited. They're like, oh, I got a bunch of data. I'm just going to do an analysis and come up with the answer. But they were asking the wrong question, and they don't take the time to do it properly. So in this project, we're going to make sure we do it properly. And part of doing it properly is using EDA to try to generate hypotheses, right? Hypotheses are just the questions that we're going to ask of the analysis when we do it later, right? And there's probably, with the data sets you guys have been finding and the problems you're working on, there are probably a million different questions you could ask. But that doesn't mean that that doesn't mean you should ask all those questions, right? You don't have time, and some questions are probably better questions to ask than others, right? Whether you're working on climate change or energy resources or disinformation campaigns or international logistics or foreign aid, whatever you're working on, there's probably a million questions to ask, but we need to figure out which ones we're actually going to ask. And EDA is going to help us do that. We're going to look into the data and try to figure out, okay, what direction should we go in? What are the interesting things, right? So just some terminology. If some of you guys have taken my classes, you probably know this, and or taken other machine learning type data science classes, you may know this, but I'm going to use this terminology this week and in coming weeks. So I will often refer to things as targets and features. Targets are simply the variable that we're trying to predict, and features are all the other variables. All the other variables in our data set that we're using to try to predict the target. Now, in some data sets, you may actually have one target, and then you may later decide, oh, you know what? We're actually going to use this other variable as a target. And now what had been the target becomes a feature, right? So you can't have multiple targets in a single data set, or you can change the target, right? But generally speaking, we have our target, and then we have our features that we use to predict it, right? There's also different categories of data, right? I'm just going to mention this. A lot of you guys hopefully know this, but if you don't, there's categorical data. Things are in categories. We have dogs and horses, or we have dogs and horses and monkeys, or we have yeses and nos, or we have people with cancer or not cancer, right? Categories of stuff. We have continuous data, which are numbers, right? Just numbers like a temperature or the amount of income somebody makes in a year. And then we have ordinal data, like ranked data, which is actually pretty common. The reason it's often put on a list like this, you see a lot of ranking data, right? People do a survey and you have these Likert scales on a scale of 1 to 5. How much do you agree with blah, 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 or how much do you like blah, 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 right? So you have your ordinal data, often treated as continuous, although technically you're not supposed to, but people do. Reason I bring this up is one thing we should keep in mind as we start the EDA process is that the type of data is going to limit the types of analytical methods we can use on it, right? So a very simple example is if you have categories of animals, right, dogs and cats, we can't calculate the average of that, right? But we could take the mode or the most frequent value or calculate frequencies, right? In some of you guys in your projects, hopefully all of you guys, will probably do some machine learning or deep learning type stuff. Realize that this principle applies to those methods as well. There are some methods that, depending on their setup, are going to work better for continuous data, or they're going to work with categorical data. Or there's some methods that need all the data to be continuous, whether it's actually continuous or you just create dummy values where you code, a category into zeros and ones, right? So this is something you guys kind of have to keep in mind is the kinds of data you have are going to influence the kinds of analytical methods you can use on it, right? There's also data visualization. So, one thing we can do with EDA is we can do stuff like calculate descriptive statistics. We can calculate averages and standard deviations, correlations, do that kind of EDA. But another very popular way to do EDA is simply to create visualizations, right? And this can help us understand our data prior to doing any of the machine learning or other kinds of fancy analysis. It also can help us identify problems. Most of the data sets you guys are going to be working with are not going to be perfect. They're going to be a little bit messy. There's going to be weird outliers, weird data distributions, or just other problems. And a lot of times we need to clean those problems up before we can actually successfully do machine learning or other types of analysis. Otherwise, our later analysis is actually going to be biased by these weird problems, or sometimes it's going to be completely incorrect. So we need to make sure we're aware of our data. Really, all this EDA stuff is about really trying to get a deep understanding of the data we're working with, right? So there are many types of visualizations we can use for EDA. I'll show you guys a few of them today because in a couple weeks, you're going to be asked to do this. I'm going to ask you to go through the data sets you have and come up with a bunch of EDA stuff and actually turn something in and talk about how you explored the data, right? So here's a scatter plot of, this is scatter plot. So scatter plot, we have our data and we can say we have two variables. We can just plot the data by just basically throwing it on a graph, basically like a Jackson Pollock art piece, right? And we can, of course, draw a regression line. We can do some things where we color code the points on the graph, or we make the certain points or bubbles bigger than other ones, right? So, but what you can do here is we can use this to help us generate hypotheses, right? So this is a good example. We're looking at different countries and different regions, and we're looking at the relationship between the GDP on the x-axis and the life expectancy, how long you live on the y-axis, right? And so normally what you'd kind of suspect is there'd be some relationship, right? If you have more money, you can spend more on your healthcare and you can eat a better diet and blah, blah, blah. And we kind of see that there's definitely this trend line, this black trend line here amongst a lot of countries. But then we also see some things that are a little weird. For instance, well, first of all, we see some things that kind of make sense given what we know. Obviously, a lot of the European countries are following the trend line, and they also tend to be high GDP, high life expectancy, not surprising. And then we have some countries down on the lower end of the trend line. A lot of these are African countries, unfortunately, who have a lower GDP and a lower life expectancy, right? So that kind of makes sense. But then we have other countries that are way off this trend line, right? So you notice there's these countries down along the lower half here: Lesotho, Swaziland, Botswana, Equatorial Guinea, where, like Botswana, actually the GDP is actually, I guess, above average, right? Or at least somewhere around average, but the life expectancy is very, very low. And one of the things this should cause us to think is, well, why is that? Right? Again, this generates a question, a hypothesis that then we can test in later analysis, right? Or why are there these certain African countries that don't fit the pattern? What's going on here, right? I can tell you that some of these countries like Botswana, the problem is certain epidemic diseases. Like in Botswana's case, it's HIV, which has a very high, I think the highest in the world, or pretty close. So there are other things going on. But if we didn't know that, then this kind of analysis, this visualization of the data is going to make us wonder, like, why is this? And then we're going to want to go off and try to figure it out, right? Same thing if you look, some other countries are in weird places like North Korea. For our friends here in South Korea, the GDP is very, very low, but they're actually above the trend line for life expectancy. Their life expectancy is actually pretty decent, which is, again, why is that? Is it genetics? Is it something with their diet? What's going on here, right? So you can see how I'm kind of walking through this data, this visualization, and just asking questions. I'm looking for things that make sense and things that don't make sense, and then asking, like, why is that? And every time you do that, that's a question, that's a hypothesis you can ask, right? So for your own projects and your own data sets, this is what we want you guys to do, is basically create these visualizations, this EDA stuff, right? And then walk through it and generate these hypotheses. Look for this interesting stuff and write it down and kind of see what you see. Again, you're not trying to answer the question of, like, how do I solve this problem of foreign aid, targeted foreign aid, or disinformation campaigns. We're just at this juncture trying to generate the questions and trying to figure out, based on the data we're looking at, what's the right questions to ask, right? So this is really what your goal is going to be for this part of the process. Now, along with scatter plots, I do want to say there are other visualizations that can be very useful. Parallelograms also, a lot of times, these are great. You can make these in Seaborn and Python, get these color-coded parallelograms, and you can start to look for places where there's like big, bright red things and big, bright blue things, and start to ask, like, does this make sense? Does this not make sense? Why is that related to that? Why is that not related to that? Or why does this have a positive correlation, but that has a negative correlation, right? An inverse relationship, right? You can start to look and see, like, okay, like, does that make sense? Does it not make sense? And a lot of it's just making these things and looking at them and looking for things and trying to spot out the interesting stuff and ask yourself questions, right? Just be curious, right? Seaborn, of course, is a Python package. Hopefully you guys have seen it before, but lots of cool visualizations you can do, along with these scatter plots, these parallelograms. You can do histograms and joint plots, which are scatter plots. You can do box plots. You can do density KDE diagrams and violin plots. Do all kinds of stuff, right? And this is just a sample of some of them. This is a bunch more. So you guys, during the next couple of weeks as you're working on this, I want you guys to be creative, be curious, take the data sets you found and just play with them and start to try to generate these questions, these hypotheses. Think about it, right? Like, does this make sense? Does it not make sense? And as you look through Seaborn and stuff, you'll see there's a ton of stuff you can do with it, all kinds of cool visualizations, and you'll be asked to actually come up with like 5 or 10 of these EDA analyses based on your data visualization, and then provide them to us. Also, I should be remiss not to mention, there's also some packages in Python that allow you to map the data. So depending on your problem you're working on, it may be very useful to create maps. So along with just scatter plots and parallelograms, sometimes if we have data where there's some geographic component, sometimes it's really useful to create these geographical maps, right? And you can do that in GeoPlotLib. There's also a really good package called GeoPandas, where you take data in a pandas format and create these maps from it. So pretty cool stuff, actually, pretty cool. So color code them and look for patterns and stuff like that. Now, as I mentioned, you can, outside of the visualization, sometimes it's useful just to do descriptive statistics, calculate averages, means, or just calculate the correlation values and just look at them by hand. Sometimes people do some simple statistical tests, like some t-testing of 2 populations, right? So there are times we want to do this. So, keep in mind that you can also do these kinds of EDA type analyses, and that you should keep all this, because later on, some of these things may be useful when it comes time to actually do your final presentation and put together your final paper. You actually maybe want to talk about how you did some EDA and your kind of thought process that led you to do the analysis that you want to do. So EDA in summary, you should always anticipate doing EDA. Any good data science project should, after you do some background research, EDA is the next step. We're going to try to come up with the right questions so we can come up with the right solutions. And once we've gone through this brainstorming process, then we'll start kind of trying to work on the final analysis, the final proposal, and actually, kind of come up with, execute kind of the game plan. And this will help us also tell good stories around how we came to the conclusions we came to, right? So this is going to be this inflection point. We're going to move from doing background research to actually starting to look at the data. But we're also, one thing that we'll look at a little bit later, I won't talk about it too much now, but also the sustainability of our proposed solution. Because we're going to see this later, because one of the problems we're going to have with policies is they need to be implemented and deployed, and they need to persist. A policy is not something that happens once. It's something that lasts for months or years. So one of the things we'll have to think about later in class is turning our analyses into a policy that can actually be implemented and persist over time. And that's actually kind of difficult, right? So in terms of this data-driven policy making kind of thing, EDA is useful to kind of start this process, right? To come up with these questions and then kind of move towards that. We'll see this later in class, like I mentioned, right? Yeah, so we'll need to think about policy goals. We'll need to think about the actors involved. If you guys watched the video last week in the global seminar, she was talking a lot about actors in that kind of policy analysis and the potential effects. Because at the end of the day, we want our policy proposals in this class, in this program, to be data-driven. Not based on our beliefs and not based on some politician's ideas about what's true and what's not true. We're data scientists. We don't do that. Right? We look at the data and we let the data tell the story. So we need to make sure that we're doing that. So the bibliographies due this week, and you should be identifying data sources. If you have not already done so, talk to your mentors about this. You really need to kind of get those together, because you need to, as soon as the bibliography is done, you need to transition right into the EDA part and start working on that, right? Because you're going to want to do not just one analysis, but a bunch of them. So you can kind of look at the data in different ways, okay? So keep this all in mind. So I'm going to pause this here, and what I'm going to do is attempt to close this down, and I'm going to switch over. So because of the policy seminar, it meant that something that normally I would talk about in these classes kind of got skipped over. So I'm going to talk about it for like 5 minutes, and then we'll wrap this up. One of the topics we didn't get a chance to get to that we really should talk about as you're starting to work with the data is this notion of feature engineering, right? So feature engineering, hopefully you guys kind of know a little bit about it, what it is, but like if I ask you a question, this is some data from early on in the coronavirus period, like what's the best country, what's the worst country, like based on this graph? And can you answer this question? Well, a lot of people would just look at this and be like, the USA is the worst, and Iceland's the best. Denmark's doing great, right? Korea's doing pretty well too, right? This is way back April 2020. But the problem is, and people do this, you see this in the media all the time in newspapers and stuff. The problem is we don't really have enough information in this chart to really answer the question. We really can't say what's the best and what's the worst. If we had some more information, like the population of the countries, and we actually then scaled the number of cases by the population, we actually get a very different story, right? We get a completely different story. What you see here is the USA is not the best, but it's not the worst either. It's somewhere in the middle. And actually the country that looks like the best is Iceland, which before looked like the best, but actually the country that is the worst, is Iceland. It looked like the best before, but once we do this analysis here, we realize that Iceland is actually not doing well. It just has a low number of cases because not very many people live there because it's freaking cold. It's very cold in Iceland. Very beautiful country, but it's really cold, right? And so if we do this kind of we take the raw data and we kind of calculate more relevant features by combining features together, we can often come up with a completely different story. And that story may actually be a lot more valid and valuable for the question we're trying to answer, right? So we see here countries that look before, like South Korea is still doing great, good job, guys. But countries like Turkey and Iran are actually, were actually not as bad as it seemed at first. Whereas, countries like Iceland and Spain and Italy are actually doing quite bad. Again, early on in the pandemic. So this data has obviously changed over the years, but you kind of get the idea here that when we do this kind of feature engineering by calculating more relevant features from our raw data, we often come up with a completely different story and a much more valid story. And so, all data sets basically are amenable to this kinds of feature engineering. We can take people's income and age and come up with a metric to figure out how likely they are to buy our product. We can figure out the average flight delays for airlines, and then we can replace the airline names in our data set with the average flight delays. And if we know the death rates for some zip code, we could create risk scores of dying from some disease like cancer or developing diabetes, right? So these are some examples, but all of our data sets are amenable to this, and probably, or not probably, like 100% guarantee the data sets that you guys are going to be using in your EDA are also going to be amenable to this kind of feature engineering. So feature engineering is definitely something you want to probably use, along with some of these other things, feature selection and feature extraction. You may want to use too, but feature engineering, especially kind of early on, is something you definitely want to use as part of your exploration. In reality, and I say this all the time, when I was a practicing data scientist, I spent just as much time doing feature engineering and feature selection as I did building models. Building models, I may have spent 20% of my time doing. The reality is you spend a lot of time engineering data, a lot of time doing feature selection. It's a really important part of the process, and it's going to be an important part of your project as well. Now, I will mention feature selection briefly along with feature engineering. So one of the problems we have in most data sets is this. So again, these things are kind of related topics, but they're a little bit different. So we have our feature engineering, but we also have our feature selection. One of the problems we have in most data sets is that the signal, the actual thing we care about, the pattern, is actually usually just a tiny part of what's going on. In most data sets, the signal is actually overwhelmed by just noise, by just irrelevant patterns. They don't mean anything. They're just, just patterns in the data that really have no bearing on answering the questions we're trying to answer. So one of the problems we're going to have is our signal is going to be overwhelmed by the noise. So feature selection helps, because a lot of times when we have a data set with like 100 features, in reality, only like 10 of them matter. The rest of them, they don't really matter. Not for the question we're trying to answer, right? Maybe they matter for other things, but for the question we're trying to answer, they don't really matter. And in reality, they're just noise. So if we can get rid of those other features and focus on the 10 things, 12 things, 20 things, whatever, the smaller subset of features that actually matter, that's going to help us come up with a better model, a better answer. It's going to get rid of the noise and help our models focus on the signal, right? It's also going to create more parsimonious models, so models that are simpler and easier to explain. And this is a huge advantage. When we go off and explain our final results to our boss or to the people at the U.S. Embassy, the U.S. State Department, having simpler models in those cases is very helpful for other people to understand what we did and why it's useful, right? Parsimonious models are useful because at the end of the day, if we can't persuade people to use the things that we've created, the models we built, the solutions, the proposals that we come up with, if we can't persuade them to use it, we've accomplished nothing. You have basically just wasted your time doing a bunch of nerdy analysis. Nobody believes what you're saying, right? And I have some examples here, but I'm going to go and end the thing here. Like I mentioned on the previous thing, you should be finishing up your analysis now. Put this in here right here. So you should be finishing up your, I'm sorry, not your analysis, you should be finishing up your bibliography this week, and then you should immediately start working on your EDA. If you have not identified your data sets, then you need to get to work on that too, because you're going to need to have some data sets identified around the same time you turn in your bibliography, so you have some stuff to start working with. So talk to your mentors about that if you have not done so. So I'm going to end this here. I hope you guys have a good week. We'll be doing an all-class meeting next week, so make sure you guys can attend that. We'll be talking about upcoming plans, upcoming events. We'll give you some updates on the travel, all that kind of stuff. So I hope you guys have a great week. If you have any questions, please do email me. And I hope your project's going well. I'm excited. We're excited to see what you guys come up with. Here in about a month, we're going to do our midterm update. So we're all looking forward to seeing sort of your halfway finished product. So okay, well, I'll talk to you guys soon and have a nice week. All right, thanks.